So our main focus is going to be on adding, subtracting, and multiplying with polynomials today. We've done a lot of the multiplying. We've actually done the adding and subtracting too, just not straightforward like it is with these. So whenever you're adding or subtracting polynomials, okay, we're going to add or subtract the coefficients. We're not going to mess with the exponents. And you can use either the vertical or the horizontal format. As we're doing them, if you find you like one better than the other, I'd suggest doing all my problems that way. Even if in the book it's like add horizontally. If you like vertically, put it into vertical. That's fine. So when we're adding polynomials, notice my like terms, okay, my terms of same degree are lined up for me, which is nice. And if you're going to do it this way, you need to do that. And basically, all I'm going to do is add down. Now again, reminder, you are not multiplying here. I am not adding exponents. All I'm doing is adding straight down. That's it. But it's another one of those things, because even when we were doing this on quizzes and tests before, some of you, when you saw plus or minus, still wanted to FOIL everything. And I was like, ah. So watch the sign to know what you're up to in this particular case. So if it's vertical, you just add down. If it's horizontal, basically it's the equivalent of combined like terms. Now be careful. Your first terms in both of these aren't always going to be the same. I only have one term that has an x to the third. I only have one term that has an x squared. But when I get to my x terms, now I do have like terms I can put together. 12 minus 2 is 10. And 1 minus 4 is negative 3. And I'm good. But again, notice I didn't mess with the exponents. Okay? Never, never, never until we're multiplying. Or maybe dividing. Now subtracting's a little trickier. Because here's what I normally look at when I'm doing this. You've got to remember when you're subtracting, basically what you're doing is you're changing the sign of every term down here in the parentheses. So some people are comfortable with that. They'll just be like, okay, 8 minus 2 is 6. Negative 3 minus 6 is negative 9. Negative 2 minus negative 1, ooh, that's tricky because that turns into plus. Negative 2 plus 1 is negative 1x, or just negative x. And 9 minus 1 is 8. Some people, real comfortable with that. That tends to scare me a little bit because I'm always afraid I'm going to switch a sign around somewhere. Yeah, basically you're just changing the signs in here and then you'd add down if you wanted to look at it that way. I am much more a fan of horizontal when it comes to this. Another thing I'm a fan of, especially when there's lots of terms, is actually rewriting the second part when I distribute the negative, which is going to change every sign in that set of parentheses. Because now what I've basically done is turn this into a combined like terms problem. I'm still doing the subtracting. I'm just doing it in a little bit different of a way where I can organize myself a little bit better. And again, I'm not picky. If you like one way over the other, do them all that way, as far as I'm concerned, as long as we're being careful with the detail stuff. Now when it gets to multiplying, this is a little different. Now we do have to multiply things out, and everybody has their own way of doing this. So here's my suggestion. A, because it organizes you, and B, so you don't have stuff all over the place. I never multiply vertically. I just don't, because there's too many things that can go wrong. So I choose instead, and again, some of you are going to like this, some of you probably not so much. What I do is I use a box to organize this when I'm going to multiply, especially when I get into lots of terms. So I'm going to take my x minus 3 down here, and my negative x squared plus 2x plus 4 this way. And what I do basically is then you're multiplying what's on the outer edge of each box. So like here, x times x squared is x to the third, but I've got that negative there. Because again, when you're multiplying, you add the exponents. X times 2x is 2x squared. X times 4 is 4x. And then I just start doing it with the negative 3. Negative times negative is a positive 3x squared. Negative 3 times 2 is negative 6. And negative 3 times 4 is negative 12. Now, am I done at this point? Well, no, I still got to combine my like terms. But the cool thing is, when you do the box, everything gets lined up for you. My greatest degree term will always be in the upper left. My squareds will take the next diagonal over. Your like terms will always be in the same diagonal. So 3 plus 2, careful, 5x squared. I'm multiplying to fill the box, but then I'm just combining like terms. No more messing with exponents at that point. 4 minus 6 is negative 2x.
I don't get how you did it with the box.
Basically, it's kind of the equivalent of doing FOIL. Actually, I'll do what you would have done here on this one, on the next one, so you can see.
The box, is that the best way to do it?
I just like it because it organizes me and keeps me from forgetting part, is basically what I'm doing. Because if I do it like I'm going to do here horizontally, and it's not FOIL because it's bigger, but basically I'm just going to distribute that x term by term first with the x, and then I'll go back through with that minus 3, and I'm going to distribute it back through.
Oh, so we can do it like that too?
Absolutely. That's why I just like showing you options on these. And you can choose to do it whichever way you want. If you're more comfortable just kind of doing it like you would FOIL, where you're just kind of distributing through, and then go back and combine like terms, that's fine. Let's see, x squared, x plus x. So you always have that option, do I want to distribute it through, or do I want to do it where I put it into this box form, okay? Again, everybody's going to be different. Those of you that don't like looking at all the lines and things might like the box. Some of you look at the box and go, yeah, no, probably not so much. So what happens when weird things start happening? Like there's 3 here. I do not have a 3D version of the box yet. If I ever do, I'll let you know. What I'm going to do in a situation like this is I'm going to take them a pair at a time. Doesn't matter which pair I work with. So like if I want to work with that first pair, I can. And again, whether you want to FOIL it, box it, I'll kind of go back and forth again here on these two to give you one more look at each. But here, like if you're going to go FOIL, so you'd be like, okay, so I got my first, my outer, my inner, and my last. And then I just combine the terms that are alike. But remember, you're not done. That's just to take care of these first 2.
Oh, and then you have to go on these.
Then I have to go, and like I just did on number 6, I've got to do that with this. So like here, I always distribute with my shorter one. So I'm going to go this way here. So x to the third, because x times x squared. X times 3x is 3x squared. X times negative 4 is negative 4x. And then I just distribute the 3 through doing the same thing. So 3x squared, 3 times 3x is 9x. And 3 times negative 4 is negative 12. And then I just combine the terms that are alike, and I'm good to go. So let's see here, x to the third. 3x squared and 3x squared is 6x squared, because again, I'm just combining like terms. And watch signs, negative 4 plus 9 is 5. And I'm set. So anytime I have 3, I got to do it in 2 pieces. I take 2 of them, work it out, then I'll work that third one in. Now, I've got a similar situation here, except I have to be careful, because I know what's going to happen to some of you. Even when I say this, you're going to distribute this squared through, you're going to call it x squared plus 25, and you're going to multiply that out. It's not going to work. And then I'm going to bring you back to this one. I'm going to say, no, x minus 5 squared means there's 2 of them, which basically now turns it into a problem just like number 7 was. Now this time, I'm going to go back the box way. If some of you are comfortable with foiling, just do it out that way and we'll see if we get the same answer. So I'm going to do these first 2 together, and I'm going to box on both of them. So here we go. Boxes can be any size. In this case, it's a 2 by 2. And I'm doing the same thing that I would with FOIL. I'm just doing my first, and then these 2 together, when I multiply them, make my outer. And these 2 make my inner. And 5 times negative 2 gives me my last. It's the exact same thing. Combine my terms that are alike, which gets me my product of the first 2. And then I get the last one in. So when I go to do that, box gets a little bigger. And again, I just always multiply the outer edges, so x and x squared is x to the third, to fill my box. X times negative 3x, x times negative 10, and then negative 5 times each of my terms to fill in the one on the bottom. A bit tedious, but again, it kind of teaches us detail work to work through. And then I'm just going to combine the terms that are alike. So whether you did that via the double kind of distributing like we did in 7, that's fine. If you did it with the boxes because it's kind of an organizational issue with you, that's fine. Find one that works and just be careful. Now, as we get ready to flip then, now this is something back here with your squares and cubes that is optional. There are things that are shortcuts. Can I still just multiply them out by foiling or boxing? Yes. Does it make it go faster if I know the pattern though? Yes. So like for instance here, when I get to number 9, I could just write out x plus 2 and x plus 2 and FOIL it out and get an answer. But what my other option is this is a special product called the square of a binomial. So if there's a number with a plus in the middle, here's how I do. I take my first term, I square it, then I multiply these 2 things together, so 2 times x is 2x, but I double it. So 2x times 2 would be 4x, and then I square my last term. I'm done. Would I get the same thing if I FOILed out? Well, let's find out. X plus 2, x plus 2. X times x is x squared. X times 2 is 2x. That's 2x. 2 times 2 is 4. X squared plus 4x plus 4. Same thing. So again, it's a personal preference. Some of you are like, if I got to try to remember a special, I'm going to forget the other stuff. Well, then I wouldn't do it. But if you are going to do it, again, square my first term. Yeah, the pattern is square whatever a is. A is whatever my first term is. So I'd square the 3 and the x. Now this is the part that gets fun. Ignore that minus because it's already part of the formula. 4 times 3x would be 12x, and double it. So 4 times 3 is 12, times 2 would be 24x, and then square the 4 on the end. And I'm done. But again, as I keep saying, foiling out works. So if you want to do that, you can. And then the only other one looks sort of like a difference of squares was before, but they're not squares. But this is how they come about. So you're like, oh, so it's a squared minus b squared. So it's whatever the first term is squared minus whatever the second term is squared. Okay. Because if I FOIL it out, the 7x and the minus 7x will cancel out. But again, if you want to FOIL it out, FOIL it out. Now, this is the one that I would make you want to think about maybe doing. Because if you remember back over to the other side, when we had 3 of these we were working with, that kind of took a while. She had to FOIL this, then you had to multiply it out again. There's a pattern to shorten these up too. And they're called cubes of binomials. And here's how they work. And it's catching on to the pattern. If I have something like this, and I'll show you both ways so you can see that it's the same. I'm going to cube my first term. Okay? Because here my a value would be x, my b value would be 3, if I was kind of looking at the pattern here. So then it goes plus 3a squared b, and I'll explain an easier way to remember this too in a minute, plus 3ab squared plus b cubed. You're like, now how am I ever going to remember that? There's a pattern to this. I cube that a at the first, right? Watch what happens to my a exponent. A to the third. The middle one, it goes down to a squared. Then it goes down to a, and then it's gone. So my degree goes 3, 2, 1, 0. You're like, okay. Well, for b, it does the exact opposite. I start with no b, so my degree be 0, 1, 2, 3. So you're just going down with the first term and up with the second one. And that's how I've always remembered how to get it into the form. Now I still got to multiply then. 3 squared is 9, times 3 is 27, and 3 cubed is 27. That goes fairly quick. Because if I were to multiply this all out, which I'm going to, it would mean I had 3 of these that I have to play with. And I can only take them on 2 at a time. So here, for instance, let's see here. X squared, 3 and 3 would be 6x plus 9. And then I still got to multiply through by this guy. So let's see here. X squared times x is x to the third. Then plus 6x squared plus 9x. And then I'll do it with the 3. So plus 3x squared. 6 times 3 is 18x. Plus 27. Then I've got to combine my like terms here. But I do get the same answer. So again, it's a comfort level. If you want to be a creature of habit and you just want to distribute or FOIL out on every single one because it's one less thing to worry about, do it. I'll never force you to say, do it and don't show any work because I want you doing it my way. No. But I am going to show one more time with the shortcut. So like if I were going to do 13 using the shortcut, I'm like, okay, kind of check this out here. So I'm going to cube my first term. I notice it's minus here. Minus a squared b. And again, my b value here is 5. not negative 5, because that gets included with my formula. Plus 3ab squared. Oh, am I going to fit it in? Minus b cubed. Okay, I squeezed it. So then I distribute my 3 here. So 2 cubed would be 8x cubed. This, when I distribute it, it'll be 4x squared. So 3 times 5 is 15 times 4 is 60x squared. Oh my. 5 squared is 25. Times 2 is 50. Times 3 is 150x minus 125. If I did all of my foiling out individually, I'll get the same thing. So again, no need to panic. If you like the pattern, use it. If you don't, well, just chalk it up to I saw it and I'm not going to use it. Now, the last two are like the story problems we're working on. Don't skip them because they're not hard. Okay, from 1985 to 95, the gross farm income, G, how much money we made, and farm expenses, how much money we spent, in the United States are modeled by this. Write a model for the net farm income. Some of you will learn more about net income as you start making more money. Basically, that is your gross income minus expenses. It's what the government's interested in when they want to collect taxes from you, what your net income is. So you're like, all I got to do then is do negative 0.246t squared plus 7.8t plus 159, and then you want me to subtract the expenses. Yes, that's all I want you to do. You're basically combining like terms with a minus in the middle. This big bad story problem, that's all it is. So again, this is just me. I actually go through and distribute when I do this because, well, I tend to forget things otherwise. So leave the first one alone and distribute that negative through. And go back and combine like terms and we'll be a happy camper. So let's see here. It's going to look strange, but it's going to be right. That would be my model figuring out the net income of the farmers during that 10-year period. But again, basically all they're telling you is subtract one from the other. And occasionally maybe add one to the other. So I've still got to read carefully, but it's something I got to pay attention to. Here's more applicable for some of you, even if you're doing like fundraising for clubs and stuff like that, you can actually figure out how much money you might be able to raise. You're trying to raise money for your trip to Spain, you decide to sell cookies. The revenue from selling cookies is given by the equation R of x equals 2.5x. The cost for making x cookies is given by the equation x plus 32. What are you selling each cookie for? If this is my revenue, how much does a cookie cost? $2.50. Write a profit function. How do you determine how much profit you make? What do I need to know? Okay, well, or how much money I took in selling my cookies at $2.50 each, and what else would I need to know how much profit I made? How much I had to spend. So basically what we're doing here is we're going to do revenue minus expenses. And we have expressions for both of those. Here's my revenue. I get $2.50 for every cookie I sell. Well, what's my cost? I'm going to subtract the x plus 32, which is going to be the cost of my cookies. Now, I can't just leave it. I want to simplify this. So you've got to remember to distribute your negative through. So 2.5x minus x would be 1.5x. And the negative distributes to my 32. And I guess you could call this P of x, profit. But that would be the equation that I'd be working with. And then I can figure out how much profit I'd make for how many cookies I sell. So if my goal was to make $1,000, I could plug in X values until I found out how much it'd take to get to 1,000. But here, okay, we sold 381 cookies. So I'm just going to go ahead and plug 381 in there for my X. We'll see if I did my math right earlier. I believe you're going to make a profit of $539.50. But that's what we're up to with these. Just some things of being able to take this type of an idea and actually apply it to something. And just actually read through it instead of saying, ooh, it's a story problem, I don't get it. And actually think about it for a minute. So on the front is the actual homework that's going along with this. This would be, now let's see if I can keep this straight. Homework check number 10. And this would be assignment number 3. And since we are doing a homework check on Friday, this will be the last one in it. It's only going to be a 3 assignment one. So that's what you got. You got about 15 minutes. Probably could knock most of this out because I didn't give you a ton of them to play with. Just a few particular ones.